Hi, I'm back. All right, so I just thought I would give you a very quick explanation of normal distribution where standard deviation is used, okay? So I want to make this as simple as I can. We have this thing called the normal curve, and anytime you've taken like a standardized test, it's a norm reference test. And when they give you a score, they give you a score that's a percentile score, and basically that compares you to other people. So this symbol that looks like a funny looking U, that's actually called mu. I had called sigma mu in the last video by mistake because I was having one of those senior moments, which I tend to have lately. But anyway, that's called a mu, and mu is just the X bar. So in this graph, the exact middle point, that's the mean. And then if you go one standard deviation above and one standard deviation below, you're considered normal. Okay. And normal is because that's where approximately 68% of the data lie. If you're within one standard deviation of normal, you're considered normal. And if you just Google normal curve, normal distribution, you'll get lots and lots of examples. And it's actually really cool stuff that we would have gone into great detail if we were actually in person. But if you have some free time, totally Google it. It's really kind of interesting. And as I had mentioned on a prior video, is statistics is great because statistics is actually one of the areas of math that you will use most likely in your life. And we offer AP Stats for you guys. So you might want to take that. You can take that as a junior or a senior. It's a great senior year math class. But anyway, okay. So which of the following is interquartile range? Okay. And then the population standard deviation. So I'm only going to show you one of them on the calculator. The other one I'm just going to give you the answers to. So this has an IQR, which is 13.5, and you do that by doing Q3 minus Q1. And then your sigma is equal to 7.3. All right, and again, I'm going to show you this on the calculator. So what I did is I entered the data into list one. Okay, so if you go over here to list one, you'll see I entered the data. Okay, so you do stat, you arrow over to calc, you do one var stats, you tell them where your list is, it's in L1, and then you hit calculate. Okay, so right here, you can see 20.5 minus 7, that's where I got the 13.5. And then right here, sigma x, or population standard deviation, we round to 7.3. Okay, so that's how you do it. Okay, one more time. You go to stat, enter, edit your list, enter it, stat, calculate, one var stats, tell them where your list is, and go to calculate. Okay, all right, so for the second one, we get an IQR of 3 because it's 7 minus 4. And it has a standard deviation of 1.6. Okay. All right. For the data set shown below in the dot plot, which of the following is closest to the population standard deviation? So now each dot represents one data point. So from 0 to 5, that's each one's worth 1. So that right there would be a 3. And then there would be 2 4s. And so on. So I took the data points and I put them in the calculator, and I put them under my second list. I put it in L2. So stat, arrow over to calc, one var stats. I have to change this to list 2, and I just entered it in list 2. I did it 2 seconds ago just because I didn't want to have you staring at me while I type, and I keep making typing mistakes. But anyway, so that's that. And so right here, 3.333, 3 1/3, that's the standard deviation, so choice 3. Okay, population standard deviation, that is this symbol sigma. Okay, what is the interquartile range? So that's 10. So these go by twos. So 2, 4, 6, 12, 14, 16, 18. 18 minus 6 is 12. Interquartile range. Which of the following best measures the average distance that data lies away from the mean? Obviously, it's not the mean and it's not the median because those are measures of center. So what works better for average distance from the mean would be standard deviation. Range is the distance from the highest to the lowest. Okay? And remember, if you are, so basically we have this, it's called the normal curve. And here is where your X bar or your mu is, your mean. And then if you are one standard deviation below or one standard deviation above, that's considered normal. That's where around 68% of the data lies. Okay, which of the following data sets would have the largest standard deviation? So we're looking for something with variation, which is totally choice 3. That shows the greatest variation. All right. So that's it. If you feel like doing page 17, feel free. If not, it's okay. Just go enjoy yourself. Go outside, get some fresh air. Take care. Say hi to you folks for me. Bye.